Let's start. When securing your C++ code, use the C++ solution. So, what is this talk all about? Personally, it comes from my experience as a security professional. I do quite a few code reviews and being asked to help with compiler warnings that give sometimes obscure message, and of course check correctness or the security of our code, because we usually don't want your code to be the one that will be abused in the next famous break to whatever. So the thing is that when I try to show our engineers how to write the proper code and try to direct them, most of the time I can see that C and C++ solutions to the same problems are being presented as a single solution. That is, one solution should fit both languages. And in my opinion, this is very problematic, and we should see why. So, first, raise of hands. How many of you are working in C environment, programming in C? Okay, I guess that all of you, or most of you, are in C++. So, you might think that this is the lecture, like, oh, Batman versus Superman, language war. No, this is not the intention. The intention here is to show the difference between the two languages, because the languages are different also from the security perspective. So, we will see modern C++ syntax, which you should all know. We will see risky code, possible vulnerabilities and threats. Risky code is code that is written in a way that is not secure, and in that way it creates a possibility to some vulnerability, that is a behavior of the program that is not intended in many cases, and that could be used by, that unintended behavior can be used by an attacker to attack your program and reach its goal. For example, arbitrary code execution, or bypassing controls, or doing some other malicious things in your system that you don't want to happen. So we'll see risky code, and we will see the C recommended solution for those codes, and I will present the totally different C++ solution. Now, this whole thing is very simple code, fit in one slide. Just a brief overview. We won't go into details. Some of the issues presented here will have multiple issues. I'm just looking on the most obvious one. Most of them come from the CWE database. It's a big database of common vulnerability that exists in code, and they show problem, explanation why the code is problematic, and solution. So, CWE 121, can anyone see the big problem here?
Buffer overflow.
Buffer overflow, buff size might not be sufficient for the input coming from argv. If the input is larger, the attacker can use argv to smash the stack. Well, for main it's not interesting, but it's, like I said, it's a generalization of the problem. Smash the stack can cause the return code to execute in a total different way. Very classic method of doing damage in code. So, that's the buffer overflow. And Batman will guide us into the C solution. C solution say, okay, use the safer version of string copy that will ensure that your buffer doesn't overflow, and use that instead of the string copy library function. Okay, good, but in C++ comes a question. You have a string. Why do you use a character for array for that? Use standard library string, and you are done.
This has dynamic allocation.
Okay, so go for the string view. Upgrade to C++ 17. String view, you don't have dynamic memory allocation. Or if you want, you can there are possibilities to do string without dynamic memory allocation using advanced memory techniques. This is also a possibility. So use the standard library. You don't have the problem. You are safe as it is.
That is if you can stay only as represented as a string. If you're not using any library that needs to see it as a...
We will see what happens when you go back to the library. Let's see in our next example. Okay, we have here character array, for example, and we want to truncate, to concatenate the string and truncate, so it will go into that library. The full name should go, for example, to a database, okay, which is limited.
Mm-hmm.
Okay, so what's the problem here? Actually, there are two. But
It's very efficient.
nah, this is C code. It's the most efficient.
Not though.
No, there's off by one.
Yeah.
Null pointer terminated. On some cases, the buffer will overflow, which you don't. Again. So again, the C convention. You have safer versions. Put them. Don't forget to take into account null terminator to the argument you are passing, and you're good. But again, this is the C way. In C++, we will be using strings because we want to use strings for strings, obviously. And strings has their operators. You want to concatenate strings, concatenate the strings. You want to extract part of the string, use substring to extract part of the string. Okay, now some of you will jump. Oh, string concatenation, the most inefficient thing. Okay, but it is obviously the most clear thing. So if you don't do that too often, your intention here is clear. And then I think that's the best thing in the addition operator. But if it's not good for you, you already analyzed and know that this is a problem for you. So there are better methods, for example, string to concatenate strings. And if the string, because you heard that strings are inefficient, which is a questionable thing, why strings are inefficient, but if the strings are still inefficient for you, there are even better libraries that claims that they can do string concatenation in the most efficient way. I didn't test it myself, but I trust the wise guys of Absol that they know what they talk about. So there are even options if you want to do efficient string concatenation, and you don't have to revert to C library concatenation, and as a result, your code doesn't suffer from all of those potential vulnerabilities, which is what we wanted in the first place. Next thing is a real life. OpenSSH Heartbleed. No, this is not the Heartbleed example, but OpenSSH is like a holy grail of attackers. To find the bug in OpenSSH, the world is open for you. This is a real problem here. And what is this problem? It's a bit more complicated.
Knowing failure of malloc, knowing
No.
Overflow of nrest multiplied by
Yes.
cyber.
Right, integer overflow. People are not so much aware that integer operation can overflow, and in the language, well, depending what language are we talking about, it is most of the time undefined behavior, if I'm not mistaken. So C++ recommendation, a C
One, I
recommendation.
think one of them is undefined, the other loops around. One of them, the
Which
unsigned and the
which
signed,
is
one
problematic.
of them is
Which is
okay.
the problematic decision from our purposes, because we don't think on undefined behavior, and we don't think, okay, it overflows, so how do I detect that it overflow? You don't have, in C++, you still don't have access to the overflow flag, at least not in the standard way, as far as I know. So this is the recommendation for C. You can already see.
Why don't you use CR to close this gap?
Because it won't solve other integer overflow. A problem is the integer overflow, not with the result. Okay, this is the example.
This specific code, replace M with C and you're done.
Okay, and what if you want to do other calculations, not only just malloc? Okay, so it's a general problem. Like I say, this is all samples. This is more explicit, but you get an integer from an untrusted source. You have to somehow validate that this integer makes sense before you use it. Okay? And, well, multiplication is easy. Addition is even more difficult to get right. This is an example of how to check that signed integer addition doesn't overflow in C. C++, again, we have a library. Unfortunately, it's not standardized yet. I think it is in the process of acceptance to C++ 20, but there are stable both boost and standalone implementation of header only saved integer. Do the overflow checks for you, and of course you can set up a policy to decide how it will behave if an overflow will occur, throw, terminate, nothing, usual stuff. So if OpenSSL was written in C++, the code might have looked like that. But of course, this is a segue to our next problem because we don't want to do it. And next issue is a bit different, resource handling. Now, let's suppose that I have my Hungry resource function that needs lots of resources to do each job. So I start with get resource 1, and then I get resource 2, which depends on resource 1. And now I have to check if the resource if we got it. Okay, we got it. So we can continue and do something with both of those resources. And we continue the function, and now we need yet another resource 3. And we didn't get it. If we didn't get it, so we cannot continue. So we have to release our resources. And of course, we have to do that in the reverse order, otherwise we are risking deadlocks. So we have to do the release in reverse order, and then we can return. Okay, so we got resource 3. So we have to do some more stuff, and then we got into some wait condition when we can't continue. So, okay, we need to exit. So again, release everything in reverse before we return. And we continue, and reach the end of this function, and we release resource 3 and resource 2, and resource 1 is valid here. I'm not sure. It's a long time ago. So this is a bird's eye view on just what we've seen, and actually the code here is just shows us the resource handling and not the actual thing that this thing should supposed to do. And you can see how complex it is. And then people come and say, hey, can we review that function? I think we have a possible resource leak or something here is wrong. And you go like that. So, C solution for that. It's a 4-letter word. And therefore, we will not discuss it much further. Sometimes it is hidden in other weird syntactic because you cannot write this thing. So you can see do while 0 or a forever loop that should only execute once or other oddities, but we won't go into that. We'll go into the C++ solution. Smart pointers. Yay! Smart pointers will just do what you want. You want the resource, they will acquire the resource, and when the resource is not needed, they will release it in the correct order.
You don't need to do just put an automatic variable there to the structure to default.
And what happens if you got an exception?
Structure will be called
The destructor of what? The resource? Resource, you assume that you have.
Either way, you assume you have some structure that handles the resource release because of the unique pointer.
So
you don't need unique pointer.
It depends on the type of resource.
We'll
if it's
see.
a C library, then you would use it. We're saying the same thing. A scope guard.
You scope guard, you write
Basically,
RLS, but why rewrite a thing that is already written and well tested in
Unique
standard
pointer
library?
only handles the memory and call the destructors. You have to
Unique,
handle-
okay.
Either way, you have to have
Unique
destructors.
pointer is an example, and we will see more usages, okay? So, the basic thing, like when I learned C++ many years ago, this was how you allocate a new object. So we don't do that anymore. You don't do new and return a pointer, just do make unique, and you have everything you need. And your resources are handled, and I do recommend to use unique pointers because
Memory handle.
the overhead, because they do well tested, the overhead is nearly 0 in most cases, and they work. They just work. They make you work in a consistent way where you know what to expect, and your code looks the same everywhere, and your intention are clear. This is at least my opinion. Okay, but memory pointers are not the only type of pointers we have. Other type of pointers, like file pointers. So you can use the same smart pointer to do file pointer operations. And when the unique pointer that guards the file pointer is getting out of scope, it will close the file automatically for you. Yay! And of course, the usage is almost the same. You don't have to do many modifications in the code. But that's not all. Yeah, question? The get. The get is the way to get the raw pointer because
I know, but you can do many.
Well, that's the big difference.
You can
Memory
get
allocation.
them free.
Memory allocation is you don't need to change anything. The raw pointer works exactly as the smart pointer. You have the you have the star operator, you have the arrow operator. Okay. Now, if you want to do some more clever things, you have to do the get. Yes, it is an open for an abuse. Well, after I think once you catch one or abuse and explains, it won't happen. This is at least from my experience. Yes, get is a bit risky.
We're talking about risk. So risk.
Yes,
I think this approach is actually still pretty risky because if you can easily not pass code, and the code.
Sorry?
I think the code is actually still pretty risky as written because you can easily forget to pass fclose, and the default deleter will be default constructed, which means it will
This is why we are using the type issue or using declaration.
No. You can write managed file t my file.
Yes, but manage file T is not just a stupid unique PTR. It's a manage file T, which requires.
Second line, if you simply don't pass fclose.
I'm not sure it will compile because you are requiring this type of destructor.
You don't pass the deleter to an ordinary unique pointer, right? It clearly has a constructor where it default constructs the deleter, right? It must.
Yes, but then you're not closing it.
Well, it will actually be undefined behavior.
Yeah.
My point is, it's very easy to forget fclose.
Yep.
And so it would be a lot better to use a class where the fclose is built in.
Of course. But we were talking about minimal requirements to make your code safe. Well, the question is why do you use C file streams in this context and not C++ streams? Yes.
It's for any resource. An example for.
It's an example, and here is another example of another resource, mmap and unmap, where you have additional advantage that the smart pointer here remembers the amount of memory you have mapped. Again, when the mapper goes out of scope, you get an unmap called automatically with the correct argument. Magically, yes. But we want to make also our Windows programmers happy. So here is yet another example where you use Windows models as an argument, and here we're taking also the advantage that the model has a pointer interface, and this way we prevent double allocation. We're just telling the smart pointer what is the type of the pointer it handles. And it works. Great. So, takeaways. Don't use char array for strings. Use strings for strings. Don't use format strings, okay? I may say if you're really, really, really big fan of format strings, and I know there are people like that, you might take a look at Andrea Alexandrescu's implementation of formatted string that does that safely for you. If you don't want to go in that path, I strongly recommend not using formatted string. Well, big question, you're writing code in C++. Why do you use the C runtime library? Use the C++ runtime library. If you need additional functionality, performance improved, there are also additional C++ functions, libraries that you can utilize for that. Don't fall back into C.
Propose a standard if you don't have one.
So?
Propose a new standard if you don't have one.
Yeah, well, I leave that to the developer of these libraries. I'm still at the find the correct library to use.
There's the FMT.
Yeah.
Nice.
And I think most important thing, use smart pointers to handle resources. Resources are just pain from security perspective as well, not only functional perspective. So use smart pointers. That's the thing where it's the most important things to do. And it works also, as I showed, in the non-trivial cases of not just memory pointers, but pointers to any resource. Bottom line, when you want to look for security solution, don't look in this book. This is an excellent book, but this is not the book you should look at. Look at this book. Okay. Thank you.